Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. In this math function lesson, we'll break down concepts step by step to make problem solving easy and clear. Let's get started. What is a function? Have you ever wondered the answer to that question? What is a function? A function is a relationship. It's a special kind of relationship between the input and the output, or you could say between two sets of numbers. It relates each input to a single output. So here are some examples of functions. F is a function, g is a function of x, and so is h. But most commonly, you'll see f of x as a function. Y is equal to f of x. So f of x could be anything. F of x could be 3x plus 5. That's a function. Y could be 2x minus 7. That's a linear function. These are all examples of functions. Now going back to this one, x is the input of the function and y is the output of the function. Now, in order for this to be a function, for every input there has to be a single output. If you get two outputs for one input, it is not a function. It's a relation, but it's not a function. Consider these 6 graphs. Which one represents a function and which one does not represent a function? Go ahead and identify each one as a function and, the ones that are not functions. Feel free to take a minute on this one. So how can we tell if a graph is a function or not? There is something called a vertical line test. So if you draw a vertical line, if it touches the vertical line at one point, it's a function. If it touches it at 2 or more points, then it is not a function. So A, or the graph that is associated with A, is a function. The graph that is associated with B, that is not a function, because it touches the vertical line at 2 points. So let's put X for not function. Now for C, that's a function. It touched it at 1 point. Graph D does not pass the vertical line test, so that is not a function. If you draw a vertical line from anywhere on E, it only touches it at 1 point, so that's a function. And for F, we can clearly see that it's not a function. At this point, it touched it at 3 points when we place the vertical line at that location. So F is definitely not a function. By the way, for those of you who want more examples on functions, evaluating functions, dealing with composite functions and like operations, associative functions, check out the links in the description section below. I'm going to be posting more video content there for those of you who needs to go deeper into this subject. But now, let's talk about the different types of functions that you'll encounter in a typical algebra or even a pre-calculus course. The first one you need to be familiar with is this one. This is a linear function. As you can see, it's a straight line, and the parent graph is y equals x. Now you can have variations of that. For example, y equals 2x is a linear function, or y equals 3x plus 7, that's a linear function. X is raised to the first power. The next level is a quadratic function, which looks like a parabola, and the parent graph for that is y is equal to x squared. So you could have y is equal to x squared plus 4, that's a quadratic function, or y is equal to 3x squared plus 7, that's quadratic, or y is equal to x squared minus x plus 8, that's a quadratic function too. The leading term is an x squared. You could have a number in front of it, or you may not, but that is an example of a quadratic function. Now let's look at the next example. This is called a cubic function, and the parent graph for that is y is equal to x cubed. Next we have this one. This is y is equal to the square root of x, and it's a radical function. You can also call it a square root function. And then there's one that starts from the y-axis and becomes horizontal. This is a logarithmic function, and the general form is y is equal to log x. So that function increases at a decreasing rate. And there's another function that increases at an increasing rate. That is called an exponential function. It's increasing at an exponential rate. And this would be like y is equal to e raised to the x. Or you could have another constant, like y is equal to 3 raised to the x. E is just a number. It's approximately 2.718, and there are some other numbers that come after that. So that is an example of an exponential function. Next, you have trigonometric functions, and these go on forever in a horizontal direction. So that is an example of y is equal to sine x. So that's a trigonometric function. These are periodic functions because they continue forever. They repeat the same pattern. Now, we do have some more functions to review. The next one is an absolute value function. I'm sure you've seen this one before, and the graph is where the function is y is equal to the absolute value of x. Next, we have rational functions. This is where the degree of the denominator is greater than degree of the numerator. So a good example of a rational function is y is equal to 1 over x. So typically, you'll see a variable on the bottom of the fraction. And then there are polynomial functions. These are functions with many terms, and the shape of a polynomial function can vary. It won't always look like that, but this would be something like y is equal to x to the fourth minus x cubed plus 2x squared minus 7. Now keep in mind that is just an example. This specific equation doesn't represent that particular graph. It's just an example of a polynomial function. So those are some different types of functions that you're going to encounter in a typical algebra course. There are some other functions, but we're going to stop it there. Now, you need to be able to evaluate functions. For instance, let's say that f of x is x squared plus 4x minus 7. What is the value of f of 3? How would you find the answer to that question? For this, all you need to do is simply plug in the value. It's going to be 3 squared plus 4 times 3 minus 7. So that's going to be 9 plus 12 minus 7. 12 minus 7 is 5, and 9 plus 5 is 14. So that's the value of f of 3. But sometimes you may have a multivariable function like this one. Let's say that f of x comma y is 2x squared minus y squared plus 3xy. So in that case, what is the value of f comma 2, 3? I mean, f 2 comma 3. In this case, just replace x with 2 and replace y with 3, and then you're going to get the answer. So 2 squared is 4, times 2 is 8. 3 squared is 9. 3 times 2 is 6, times 3, that's 18. 8 minus 9 is negative 1. Negative 1 plus 18 is 17. So that's how you can evaluate a multivariable function. So that's it for functions. Thanks for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.